Hello everyone. In this video, we are going to discuss about the basics of what is meant by process synchronization. To understand process synchronization, we need to know the two different types of processes which are available. One type of process is called as the independent process, and the other one you call it as the cooperating process. Now, what is meant by independent process? Say, for example, I have two processes, P1 and P2. Okay. Now, if P1's execution does not affect the execution of P2, and similarly, if P2's execution does not affect the execution of P1, then I can call P1 and P2 as independent processes. Okay. Again, say for example, I take the same P1, P2. Now, if P1's execution affects execution of P2 and P2's execution affects execution of P1, then I say P1 and P2 are dependent processes. They are dependent on each other. In this case, I need to make sure that both these processes are cooperating, because only when the execution of one process affects the execution of another process, that is where synchronization will come into play. If the processes are going to execute independently, there is no need for synchronization. But what we need is, we need the processes that are going to concurrently execute and whose execution is going to affect the execution of another process. Those processes must cooperate with each other. So that is what is meant by cooperating process. So I hope you're clear with what is meant by independent process and what is meant by cooperating process. So whenever we talk about process synchronization, we only discuss about cooperating processes. Okay, so now if you look at the point number 1, it says when two or more processes cooperates with each other, their order of execution must be preserved. Otherwise, what will occur? Conflicts will occur in their execution. And if at all conflicts occur, then the output that will be generated will not be the desired accurate output. Hence, cooperating processes are very important in the scenario of process synchronization. So, how do we define a cooperative process? A cooperative process is one which can affect the execution of the other process, or which can be affected by the execution of other processes. So these are called as cooperating processes, and such processes must always be synchronized. Why should they be synchronized? Then only they will guarantee their order of execution, and then only we will not have any conflict. So process synchronization mandatory requires the processes in them to be cooperating with each other. Now, what do I mean by conflicts occurring? Conflicts might occur in the execution, and outputs may be produced in a wrong manner. For that, we will look into something called as a race condition. So for that, we will take up an example to show how the conflict will occur. Now, let's say I have two processes, P1, P2. Okay, now I have a variable here, which I am calling as shared. Okay, this shared I am initializing to 10. So this variable is an integer variable which is initialized to 10. Now what I'm going to do is, I have the code for process P1 here, and I have the code for process P2 here. Look at the code for process P1. In X, I'm storing the value of shared. Then I'm incrementing X. Then X enters a sleep mode. Then the value of X is stored in shared. Same way, similar statements are given in P2, whereas just the Y variable is going to be decremented instead of incrementation. That is all. And the final value of Y is going to be stored and shared. So this is the code of P1 and P2. Now, assume P1 and P2 are executing concurrently. That is at the same time. Now, as I told you, the value of shared is 10. Now, let's say P1 is starting first. Okay. So what will happen when P1 starts first? The value of X will now be 10. Okay. Now X is incremented. So X now becomes 11. Okay. Now assume at the same time P2 also starts. That is when after starting of P1, immediately P2 follows. So what happens now? Y will take the value 11. Y will take the value 10. Okay, here Y takes the value 10. The shared value is 10, right? So Y takes the value 10. Then here Y decrements. So what happens? Y becomes 9. Now, when P1 executes this last statement shared equal to X, here shared value becomes what? What is the value of X? Shared becomes 11. When P2 executes the statement, shared becomes, what is the value of Y? It becomes 9. So here there is a contradiction. Contradiction between these two values. Here, with respect to P1, shared is 11. With respect to P2, shared is 9. So this is where conflict occurs when both the processes are executing at the same time, and one process's execution is affecting or gets affected by another process execution. What is the reason behind this conflict? The reason behind this conflict is because of the variable shared. Variable shared is a common variable being used by both P1 as well as by P2. And that is why we have this conflict occurring. This kind of a conflict only is called as the race condition. So race condition is this. The conflict that we just explained now is called as the race condition. So when we want process synchronization to exist, we should not have race condition. Okay. So this is what I'm defining as race condition. Race condition typically occurs when two or more processes try to read, write, and possibly make the decisions based on the memory that they are accessing concurrently. That is, here both P1 and P2 are accessing shared variable concurrently. And that is the reason why the shared data value is mismatching. This is called as the race condition. And for achieving process synchronization, we do not want race condition to exist. So the procedure which is involved in preserving the appropriate order of execution of cooperative processes is known as process synchronization. So what you need to know is, if you want to achieve process synchronization, then both the processes must cooperate with each other. Whatever be the number of processes that are going to execute concurrently, they must cooperate with each other, and at the same time, race condition must be prevented. It should not be existing. Then only process synchronization can be achieved. I hope this was clear. So we will end this session. Thank you.